Python and Clojure on the back end. And in previous lives, I've done JavaScript and CoffeeScript and worked on browser extensions and things like that. So I'm going to do a quick intro to Clojurescript, assuming that you haven't got much Clojure knowledge. Does anyone have any Clojure knowledge? Cool. So why would you want to do Clojure? This is Rich Hickey, the guy that wrote Clojure, and he had an idea that maybe everything in its current state, which was Java at the time, isn't so great. So he wrote his own language. Why would you use Clojurescript? So I guess go through some Clojure features first. So it's a functional list with a bracket, lots of brackets. You know the score. Its main thing is a very big concentration on immutable data structures, immutable collections, immutable dictionaries, sets, vectors, lists. And this is kind of fundamental to the whole difference in programming Clojure compared to, say, Python or JavaScript or Ruby or Java even. It's dynamic, just like the first three. And uses structural sharing, which is clever algorithms to make using immutable data structures pretty efficient compared to just copy on write, which would be the basic thing you'd use without knowing them. And any mutation you do is controlled explicitly with explicit functions to say, I'm definitely changing this, and you're right, waving, holding your hand up and going, I'm changing this. It's got a really good shell experience, call it the REPL. It's kind of central to how you're meant to develop in it. Always at the shell, changing things. You can reload code, hot load code from your editor straight into the running environment, and off you go. It's the new code's running. If you've got a web server running and you change one function, this is on the back end. You can load that function again, and then all your requests suddenly are using the new code, which is pretty nice. And it has a lazy sequence API that extracts over most data structures, which comes in really handy. Let me put it in a moment. And because it's a Lisp, it's homoiconic, which means the language can be extended with macros rather than having to wait until the next version of the language. And some quite interesting features and libraries that come up using those. So, Clojurescript. Let's move on. Saw this last week. So, Clojurescript's history came out in 2011. It's not like CoffeeScript. It's not just a syntax layer with mostly with keeping all the JavaScript semantics. It's brings the whole of Clojure, standard library, everything you know about Clojure comes over to JavaScript wholesale. And it uses the Google Clojure library to do lots of heavy lifting that the JVM libraries would do before, and emits the code designed for the advanced compilation mode of the Google Clojure compiler. So that means that there's lots of dead code elimination when you want it in production. Okay, and this guy, David Nolan, became the maintainer of Clojurescript soon after. Many performance optimizations done by him. It wasn't perfect when it came out, but since then it's had quite a number of things added. Source maps, now we have full source maps, even in advanced compilation mode, so at any point errors and logging, you can see where it is in your Clojure code, rather than having to look at the generated JavaScript in the browser. Core async is an example of a library that uses macros to implement language features. This essentially removes all your callback problems, allows you to have sequential code, imperative-looking code that's operating on asynchronous computations, asynchronous I/O and stuff like that. Makes a massive difference for me. Yeah, there we go. If you know the Go language, it kind of basically copied their API, and you have their concept of channels, which you put little kind of queues, you put values in, and Go routines, which are like virtual threads. In JavaScript, you can treat them as kind of virtual threads, they're their own thing, but in reality they're mapping to a state machine which creates the callbacks for you, and you don't have to think about it too much. In ES6 generators, they kind of give a similar option of helping you with callback problems and asynchronous. And it's also good for communicating between the components, because you can have channels, subscribe, publish, and merge, and all these operations over them. So recently, the compiler has been had a lot of work done it to make it a better experience, not just for Clojure people, because up until recently, it was kind of, if you're into Clojure, then using Clojurescript's very easy. Just all the same build tools, all the same things. Just add it as a dependency, and off you go. But for people who want to come from front end and say, oh, I like this, they don't necessarily want to have to go get their whole Java environment going with all their Clojure build tools and integrate it with that. It's not very easy to integrate it with your JS build tools. But so the last few weeks, it's been really, really easy to build without using the standard Clojure toolchain. This is just an example, kind of taken from a blog post from a few weeks ago. We've got two files here. Your really tiny Clojurescript file, just enabling printing, so you can print the console and then printing. And then here's the HTML file, just loading the generated JavaScript. And then because we don't need in the last few weeks, Clojure, you can now build Clojurescript from a standalone jar, which means you can call it from any build tool that you have that you use. So we create a build script in Clojure. It's like 5 lines long. Just says where your source directory is, and where's it going to go, and what's its main. And you just build it with that one command. You can put that into your grunt script or Gulp or whatever you choose to use. So here's going to go a bit through some comparisons of a few JavaScript and Clojurescript. So I've got JS at the top, obviously, and JavaScript at the bottom, just a made-up function add. As you can see, Clojure doesn't have a return. Everything is expressions, so the last value is the thing that comes back from the function. And again, an example, that's the full function syntax. You can add doc strings as well, and metadata. And then we have our anonymous ones, fn, when you need to, makes it easier to pass in other functions. And then a really, really small, when you don't even need to name your arguments. And I give an example of the ES6 arrow functions, kind of also pretty small. Higher order functions are kind of the bread and butter of functional programming, passing functions to other functions, calling functions other functions. So how might you map over an array of numbers in JavaScript, assign its numbers, call the map method, inline function, anonymous function, return a thing. And in Clojure, you could call the map function with a shorthand syntax and on the vector of numbers. ES6 makes it a bit nicer than the first example, fat arrow syntax. And here we have the way you can do it in function programming, partially apply, times and 2, and then you have a function of one argument that's when you map it over the each list. And we also have 4 comprehensions, like list comprehensions in Python. And yes, then is going to get them probably. And you can see it's pretty similar looking syntax. And there's a whole site with comparisons between JS and Clojurescript. That's pretty good. Have a look at it. Okay, so I told you the big thing was immutability. So here we're defining a map, like a dictionary, of key A, value 1, key B, value 2, and there's each value. And this the associate function associates key with a new value. So we get add a C key with 3, and then we get a map with 3 key value pairs. But we can see the old map is unchanged. So everything always returns, if you're using the immutable data structures, everything always returns a new value. So how do you manage that? It's not. Just a quick example. There's loads of functions to make it easier to compose how to change immutable values. This is one example of threading our map through a bunch of functions that return a new value, and then we deal with the new value each time. So we get our map, add a new key. What the threading thing does is threads the value down through here and inserts the result before as the first argument to the function. So here we add new key C, take away A, we update applies the function to the value of that key, so we're incrementing value of B, and then we're merging another map with some more complicated keys and values. And here we see the results. No more A, C's there, B's got one more. And also you can have sets as keys, and this is what it expands to when you just macro expand it. So it's code generated to make it a bit easier to deal with in your head. About a year and a half ago, a year and 4 months ago, that guy David Dunn again, he did a blog post about he'd been looking at React. Someone had been telling him, look at React, I think it really works with functional programming. It has a kind of property that would be good for us. And he had a look, and then he realized that you could actually, not only would it work well, you could actually get a better performance with the immutable data structures that Clojure has. So he announced this thing called OM, and it uses it's a wrapper over React.js, and using Clojure's immutable data structures to gain performance. To gain performance, and how it does that is normally React assumes it has the lifecycle methods, and there's one called should component update, and that defaults to true, because in JavaScript any object is usually mutable, and so you can never be sure if since the last time you saw it, it's been changed or not. So they out of the box it does the safe option, and does a breadth first search across the tree of objects, and you're passing down through to your components, and that's pretty slow if when it doesn't know what's going on. So with the mutable values, you can do reference equality. So when it sees the value that it gets, it can go, is that the same reference or pointer as I saw before? And if it is, then it's the same value. Values can't change, so it just does this pointer equals that pointer, and that's it. Doesn't need to do any searching or anything. So that means a lot less checking goes on. And actually, in the latest blog post from React, well, we've probably got a new one today about React Native, but talking about React 13, it's going to come with It's going to give you warnings if you mutate your objects in between state changes, and that's a precursor to introducing optimizations which assume you're using immutable values in JavaScript. And they've always said that you should use immutable values for React anyway since the beginning, and they've got their own implementations. And OM also has these things called cursors, which are kind of a bit like lenses, kind of views into subsections of data. So you can pass to your sub-renderers or sub-components, you can pass a smaller window into that big data structure. And so it only has to do checking on that small amount, and also the component only knows about that amount. But it can still update, if it needs to update the value, it can still update it, because the cursor itself knows how to update itself. So let's look at a basic example. Got two examples here of the same thing, same result. The first one is out of the box, with no sugar. It looks like just making a header H1 with some data. So we've got our text. This is where we init our whole app. It's called a root. We pass in our component function, and this is our app state. It's just a simple map with one value in. We put it into the DOM, and this will get the. This follows the lifecycle methods of React, and it will render the text part of that map with a class title. And there are a few libraries to make that a bit less verbose, because here we've got reify and iRender and stuff. This is implementing the kind of interface that React expects. The minimum you need to is render. There's a few others, should component update and things like that, render state. It's got all of those if you need them. So here we go, using kind of CSS style selector data structures. So here we just need to, it's a vector and a keyword, and you can put your class name after your element type. And that makes kind of some people prefer that, some people prefer the functional way. And there's also another library which lets you write HTML and inject into the HTML if you prefer that way. It's not opinionated on its own, it just does the native React stuff. And just to show, there's another library called Reagent, which came out a few months after OM. It's some people say it's a lot simpler to get into. Certainly has a simpler model on the face of it, and it's out of the box. It's got the same selective style data structure, and I checked that out as well. Especially if you're just starting out with Clojure, it's a bit simpler to get into. OM tries to be more. It's more pure about its concept of time, life cycles and stuff. But Reagent's really powerful. Just good to know. But I'm most familiar with OM because I started with that when it came out. But definitely look at Reagent. Cool. Now I'm just going to go a bit of a quick demo, just to show you roughly what the development cycle is like and what features it can do. So here we've got a tiny app. It's a couple more components than the one before. In the basic OM style, and also, where is that? Here's the page. And what we have is this is running this thing called a fig wheel, which is a automatic. It's a watching your files for changes, and it will it's connected to your browser, your WebSockets, and it will update as you change things. So if I add in this paragraph, hello, save it. That's changed. And also you can see down here we get our logging. I've logged hello, you probably can't read that. But this shows us that if you see where it came from Clojurescript file. That's because the source maps are working out of the box. And then you can see our Clojurescript source inside Chrome. And you can even add breakpoints and stuff, which is pretty handy. Another useful, really good feature in Figwheel is if you make a syntax error, it will come up here with the error and the line. So you don't have to just look at a separate terminal to keep on checking whether anything's broken. Sometimes you forget which one you're looking at. So if we fix that, it's fine again. And essentially, when you're building a component, you kind of build functions. If you're familiar with React, anytime you want to build a more, if your component's getting too complicated, or you want to separate out, extract functions and stuff, you can create new functions, and they'll be their own sub-renderers. And then you can pass, if you've got a really complicated app state, then you can pass along a smaller amount. So your component is more portable among different apps, rather than having to know about the whole tree, the whole massive of your app state. If I didn't mention before, generally what you do in OM is use a thing called an atom, which is it's a mutable reference to immutable values. So this is one of the things that you do change in Clojure, and so the value inside is immutable, but the app state itself is a reference to some other value. So when you want to change it, you pass in a new function. You can update the states, and it's kind of specific. I'm changing the state, and when you change it, so I can go here and I can change what it says. If you can see that. So here I'm calling that app reset, which just changes the whole value completely. I'm changing the value of it to hello people. And if we go look at the thing, it's already changed up there. So anytime this REPL is connected to anytime you change anything, it knows, and the new data filters down through the components. And we can also, because we're connected to the browser here, we can do a standard alert. And that will also pop up. So all these things mean you can be very at home with your code. Your browser's running, and you can check what the value is there in the terminal. Load your make new things to functions, test them in the terminal, test them in the browser. It's a very nice way of working. So I made, basically I just learned OMS so I could use OM when I was writing this little app for table tennis that we use to, we're running a league at the moment. So you've got lots, it's kind of interesting how easy it is to make kind of tricky components like this one, kind of like the BBC Premier League one. and that's its own component. And these logic is very easy to add. I just couldn't believe how easy you just start adding kind of complex components, and updates happen straight away. If anyone else updated it, it would appear here. Secondly, you got and these components kind of, anytime you change anything, it all updates everywhere, right? As you expect from React, and it's really performant. And a really cool feature of OM is that you can add instrumentation. So this is kind of a new. You can have instrumentation on all your components. See how long they took to render, how many times they rendered, so you can work out which ones are slow and which ones are rendering a lot of times. You can find troublesome components if you've got a complex app that has performance problems. So if I go back to this is just an example of the last 10 components. It's kind of messy when I first wrote it. Did all the logic in line. You see what a kind of mid-complex component looks like. But I just kind of wrote it as I went. It didn't really pause. It just was really easy. Then I converted it to the hiccup style. Makes it a bit neater, less noise. Easy to see the logic, where it's just the HTML generation. More things. So if you're starting a new project, there's a couple of project things that are really helpful. Chestnut gives you an out-of-the-box OM with the library loading routine, and Tenzing is another one that uses a new build tool called Boot. Does the same thing, but also gives the option of a free agent. Up and coming things. Reframe is a very new thing. It's kind of built on Reagent. It's got more. It's got opinionated about things like reactive programming and definitely unidirectional data flow. Then there's a thing called Ambly, which is a REPL into. It's a Clojurescript REPL for iOS, so you can do the same kind of REPL things I had there, but into your phone. And React Native that came out today, I think. But the author of OM spoke at ReactConf, and he's been pondering OM for React Native. So then we'll be able to do the same things in the mobile targeting iOS's components, and hopefully Android. Wrapping up, just a few people that actually use it in production. Prismatic, their whole site, they're like a news aggregator with machine learning. Their whole site is Clojure and Clojurescript. They really like OM. Circle CI is like Travis, but different. Their whole front end is Clojurescript, and their back end is Clojure. And they actually open source their whole OM front end with GitHub, which is really interesting because it's probably the biggest front end app you can go and look at in Clojurescript. So if you want to see how it looks like in real production, it's a good place to start. And then if you want to do this kind of stuff in JavaScript, similar, using these ideas, there's a few things that have taken influence from Clojurescript and Elm and stuff. There's Omniscient, which is this is a React library that uses, well, it says it's going to be like Om and Quisin, which is another Clojurescript library. Uses the idea of Om to, and it uses immutable.js for the immutable data structure. So it gives you the Om performance, but all in JavaScript. And JS CSP, as I mentioned before, generators can give you same kind of benefits that core async can. So JS CSP is one library that copies the core async API and uses the S6 generators, and then you get your channels and Go routines. It uses yield. Yeah. And then the Atomo, if you need an atom type thing, mutable reference, there's one of those as well. And then if you want to go even more or less production ready, more out there, Elm is really awesome. It's kind of got Haskell syntax, and it's got the similar things, immutability, but it's typed. It's got really good type inference. The time travel debugger is really worth checking out. It's amazing. You can kind of play a Mario across the screen, and then you can go and change gravity, and it will show the path that you moved, and it will change. If you change gravity, it will adjust this whole path that you would have taken. So, and then you can move the slider back and forwards and change all the parameters, and it's kind of it captures the whole time and path, and if you adjust anything, the whole path you took changes. And that also has a virtual DOM library, and that solves the callback problem in a different way. And then there's PureScript, which is like a Haskell, strongly typed Haskell type thing, but it compiles to readable.js rather than having its own library, massive standard library at runtime. It's designed so it gives you a much smaller payload on the browser. So if you want to go, if you need to have a low weight JavaScript, but still want to use one of these new languages, then it's a good one to look at. I think that's it. Any questions? Hi. Yeah, John.
Me?
Yeah.
All right. If you wanted to write Clojure today, both on front end and back end, is it feasible to use Clojurescript over Node, or would you recommend staying on the JVM?
As you mentioned that, it is possible to, as far as I'm concerned, in Reagent, you can do the so-called isomorphic apps, where you run where the first hit to the server gets you back the HTML generated on the server, and then the rest is done in the client. Do you mean is it feasible to use Clojurescript as a back-end language in Node?
Yeah, is the tool chain there, or the API
the Node is coming along. There's the Node REPL exists. If I was, I don't know what targeting Node libraries is from Clojurescript in general. If it suits you, you can do it. Not as many people do it. I mean, people do it for the to render on the server first, the first hit. I don't know how many. Oh no, I do know because the app Lighttable, the editor.
Mm-hmm.
That's all written in Clojurescript on. It was no WebKit. They're looking to Atom Shell. But if it was me, I'd do Clojure JVM on the back end because you get all the threads, you get multi-core threads and all the advantages of that. And most of the Clojure ecosystem is, in the back end, is suited to that. But you can definitely do it. They're definitely working on Node support. There is inherent Node support, so you can do what you want. Just depends whether it works for you.
Thanks.
Anyone else? Yeah.
So how is Om actually keeping up with React? Is it meant to be a direct code, like just keeping up with all the recent changes, or adding any value on top of what's already there in React?
It does keep up with the releases. It does add the value it adds, where you get the performance part, and get the Clojurescript part. So you don't need you don't need anything else from JavaScript. You just want it to render for you. And what do you referring to anything in particular?
No any particular features apart from the performance, like any other features which are different compared to what's there in React?
You mean as far as React offers? Well, it's a different model. You can add your own. There's some people have made like you can change how you. The cursors thing is a separate thing to React, and the way you use the app state to derive. You can derive values and have functions. Call them when your state changes. You can have that go through a processor change to derive values, not just do the pure data. As far as the other things like WebSockets, core async makes it a lot easier to deal with those things, and so you can add anything Clojure really. It's hard to think because I haven't done that much React on its own. I've just done the tutorial, and but it's hard to think as a Clojure person what I'd lose when I get to JavaScript. It depends. There's definitely lots of things that Clojure has. It's hard to think what OM has on its own, but there's lots of different ones. Like there's some of the libraries that go for the FRP thing, like Elm. There's like an Elm clone, and some of them you still use React. So they use React as like the final thing before the browser to render it for you. So it's like I want to do my app in my way, but React's really good at the rendering part and the performance part. So you get the whole benefits of the Clojure ecosystem. Anyone else? Okay.
For PureScript, there's also a level for React. It's called Blurmart, the creator of PureScript. My question is more targeted to the stuff that you've built in Clojurescript, particularly the architecture. Are you using a combination of cursors and core async?
That's
because I'm more from the FRP world.
Yeah.
I'm trying to figure out, like on a larger scale, pros and cons between the two. Maybe if you have dug more into the Circuit CI system. So maybe you know what they're using.
Yeah, I know some people don't like cursors mainly because of the fact that you can write to them. So it kind of disobeys the one-way data flow thing. That if your bottom component starts writing to the state. So some people say I use the cursors as a read-only lens, but then I send my data on a channel, so an event all the way back to the top, and then you have a kind of writing process to deal with all the events and whether it should write it to the state or not. And that reframe I mentioned is more of a FR or RP, reactive style. Like definitely, we don't like cursors. That's what they say. We definitely say no to cursors. We want derived data or passing through, and then you send. If you need anything to write to your thing, send it on an event. Use core async. Circle CI, I've looked into their code a bit. Mainly to find out how they did the routing, and they use core async for the routing. So I kind of use core async for my routing. So some people think you shouldn't really write to cursors, even though you can. It's cool that you can, but maybe you should separate that out into events that then are dealt with in one place, depending on the type of event. Does that answer your question? But I'd look at reframe if that's...
Yeah, I agree. Like I don't believe in cursors as well because you break some guarantees that you get from it.
Yeah.
So it's for me, it's more like FRP versus CSP. Like.
Yeah. Oh, versus, yes.
Yeah.
Yeah, because the FRP says it's very... If you choose your model, then if you do pure with Elm style, then you kind of whether you can leak in or out of the loop is sets you in one way of doing things. Cursor's kind of more freeform, which can end up being like, oh, I can just mutate that whenever I want, and you're back to kind of what I just said was bad. But I haven't done a massive app production app yet, so I can't really say that. But I will say one thing. One of the guys, Brandon Bloom, that worked on the Circle CI app. He doesn't like cursors either. He's very opinionated, and he's giving a talk on it's called like writing Circle CI's front end in ON, and he's doing that at Clojure West in, I think it's this month or next month. So check that out.
Cool. Thank you very much.